Hi everyone. So the purpose of this video is just to give you a few more challenging problems to think through. In our other videos about Chapter 21, we spent a lot of time going through the mechanics of how to construct a confidence interval, how the interval is a little bit different if we're working with proportions versus means. We talked about how to interpret the interval. We talked about why we construct a confidence interval in the first place. Now we want you to really be able to apply some of that information and to reason through some other types of problems that we could throw at you. So let's begin here. So is this a true or false statement? A 90% confidence interval for a proportion is 0.442 to 0.542. This means the sample proportion must be 0.482. So you might be looking at this and you might be thinking, well, I need more information to figure this out. I'm not given a sample size. There's certain things I don't know. But you do know a lot, actually. So you have an interval. And you also know that the general format of a confidence interval is that you take your sample statistic and you add and subtract the margin of error. So I'm going to refer to that as the MOE here, margin of error. So the sample statistic always forms that foundation of our interval. That's the center of the interval. So you start with that and then you add something to it and subtract something from it. So if you are given an interval, you can actually work backward to figure out what the sample statistic must be because it has to be right in the center of the interval. So to find the sample statistic here, I simply average 0.442 and 0.542 to get what's in the center. And if you do that, you're going to actually end up getting 0.492. So obviously 0.492 is not 0.482, so this would be a false statement. But again, you can begin with an interval and you can work backward to figure out what the sample statistic will be. You can also work backward to figure out what the margin of error will be. So that's where the next question comes into play. True or false? A 90% confidence interval for a proportion, again, is 0.442 to 0.542, so the same interval here. This means the margin of error must be 0.10. Well, how can we figure that out? We already know that the center of this interval is 0.492. So I need to figure out now how far away is 0.492 from 0.542 and 0.442. So it's going to be equal distance away from each of those bounds. So one thing I could easily do here is I could just take 0.542, subtract 0.492, that's going to give me 0.05. Similarly, I could take 0.492, subtract the lower bound here, that's going to give me 0.442. Again, that's 0.05. So the margin of error is 0.05, not 0.10. So again, this is a false statement. But you can always work backward when you're given an interval. So even if you know nothing about the sample size, and even if you don't know the confidence level, you don't really need to know that here. As long as you know the interval, you can work backward to figure out what the sample statistic must be and what the margin of error must be, simply by keeping this particular general format in mind, keeping in mind what it is we're doing when we're building a confidence interval. Another thing that you can do here to figure out the margin of error is just figure out the overall range between your lower bound and your upper bound. Here that would be 0.542, sorry about my writing, minus 0.442, that's going to be 0.10, and we'd have to divide that in half, and that's again because the overall range here is 0.10. Our sample statistic's right in the middle. It's halfway between those two numbers. So half of 0.10 would need to be added to the sample statistic to get the upper bound, and half of it would need to be subtracted from the sample statistic to get the lower bound. So again, that would be 0.05. So we figured out here, just from knowing this interval, that our sample statistic's 0.492 and our margin of error is 0.05. So that's going to give us the lower and upper bound. So let's try this again with a new example. So this particular example is about proportions. Let's try a new example now about means. So a medical researcher constructs a confidence interval based on data from a random sample of healthy adults. Each adult's resting pulse rate was measured in heartbeats per minute. We are building a 95% confidence interval. It ends up being from 70.5 to 75.5. Based on this information, we know the sample mean must be what and the margin of error must be what. Well, again, thinking back to what we just did, the sample mean, that's the basis for our interval. We take that and add and subtract a margin of error to get this interval. So the sample mean is going to be the average of these two values. When you figure that out, you're going to get 73. So 70.5 plus 75.5 divided by 2 equals 73. And then how far away is 73 from 75.5 and 70.5? It's 2.5 units away, or 2.5 heartbeats away in this particular case. So again, I'm figuring out that the center of the interval is 73 because that's the average of these two values. And then I know that 73 plus 2.5 is going to give me 75. And I know 73 minus 2.5 is going to give me 70.5. I should have said plus 2.5 will give you 75.5, but hopefully you're getting the idea here. So again, we know nothing here about sample size. We don't need to know that to figure this out. We're not really trying to plug anything into particular formulas here. We're just working backward based on what we understand about that general format of the interval. Sample statistic plus or minus margin of error is what gives us our confidence interval. Okay, so let's try another problem just so you can, so I can challenge you a little bit more. Okay, so let's try this one. You'll love this one. It's a little bit more difficult. Let's say that we have a 90% confidence interval for a population proportion. We've calculated this based on data from a random sample of size 200, and the interval ends up being from 0.36 to 0.50. Which of the following would be the 99% confidence interval calculated from the same data? So again, we're not changing the data. We still have a sample of size 200. We're imagining that instead of building a 90% interval, we've built a 99% interval. So which of these do you think makes the most sense? So I want you to take a moment and just look through these. Think about what you know about confidence intervals. Think about how changing the confidence level, for example, think about how that affects the width of the interval. Think about where you'd expect the center of the interval to be based on what you know here. What would you expect your sample proportion to be? So I'm hoping that right away there are a few things here that you can easily eliminate. So right off the bat, I would say D, B, and A are all things that we can eliminate. And I'm hoping that you're thinking about the fact that if this is the 90% interval, the 99% interval would have to be wider if we're using the same data. And obviously, answer options A, B, and D are all more narrow than this original interval. So that leaves us now with options C and E. So how can we figure this out? How can we figure out which one would be most appropriate? Well, we could maybe make sure they both have the same centers. So what's the center going to be here? So what's our sample proportion? 0.36 plus 0.50 divided by 2. That's going to give us 0.43. So unfortunately that's not helping a lot because both of these have a center of 0.43. So what are we going to have to do here? Well, now we are going to have to plug some things into formulas to really know for sure which of these options we're going to have to choose. But we have all of the information here where we can easily do that. So we know our sample statistics 0.43. From that, we add and subtract the margin of error. So our confidence level is 99%. So we take 2.576, that's our z-star value. And then we take 0.43 times 1 minus 0.43 divided by 200. So I'm hoping that you're seeing that I'm just using that general formula for a confidence interval for a proportion here, since I know that I have data in the form of proportions. Okay, so I've just plugged everything into this formula. And then when you work through this, and I encourage you to do this for extra practice, you're going to get 0.43 plus or minus about 0.09. So now I'm hoping that you see the answer would have to be C. So again, this is a little bit more of a challenging question, but it brings a lot of things into play that we've talked about. So to really answer this, you need to have an understanding of how the interval is going to change, how the width is going to change as the confidence level changes. Remember that as we increase the confidence level, the interval will get wider. You have to think about, again, where you would expect the center to be. So we would have to know the center of the interval to even be able to use this formula at all. If we don't know p hat, we're not going to be able to kind of work through the formula and figure out in the end what the answer must be. And we'd have to also, of course, know what the z-star value would be for a 99% interval. So again, I hope that kind of thinking through these particular problems is helping you understand the big ideas with confidence intervals. If not, please let me know. We definitely want to help you reason through this. We know it's challenging material, but we hope that thinking through these problems will help you when it comes to completing upcoming assignments and assessments. So thanks everyone, and we will talk again soon.